Okay, so now that we know what relations and functions are and how to test for them, it's basically, again, one thing in, one thing out. Let's talk a little bit more about the sets that they're putting together, right? So for every rule, for every relation or function, there's a set of inputs and there's a set of outputs. And they actually have names. So the set of inputs are what we call domain, and the set of outputs, right, are what we call range, right? And usually students kind of stop right there, but there's actually more to the story to help you understand. So it's just not my x values and y values, right? The domain consists of a set of inputs that actually create an output. They, in essence, make the relation work. And that is very important. All right, because we have this rule hanging out, right? We have this idea, and we got to make that idea work. And so we just can't put anything in it, right? It's got to be something I put in that actually creates an output. And then as soon as we have some outputs, we now have a range set. But that also is half the story, because they have to, that's the word R, by the way. All right, so the range of the set of outputs that are created by all that inputting. So there's some action going into this, right? So that's what's kind of missing from a lot of domain and range. We kind of forget that there's this action going on. We're putting something in, right? If it makes the relation work, it's in the domain. We're getting something out from that input, so that's putting us in the range. So, right, so we're not just talking about any old x, y value or any old y value, right? They have to be something that actually makes the function work. And so let's go use that definition up here. Before I do that, this concept of a set, that also is kind of a double-edged idea, because what we're talking about in a set is we're talking about a collection of objects that are related to each other. So again, what's the set for domain, or these are all the x's that make the function work and create an output. So that's what puts those inputs together. The range, right, that's also another set, collection of objects that were created by all that inputting in the relationship. And there's two types of sets that we're going to be working with. There's what we call discrete, and there's what we call interval. And rather than getting really wordy, let me just go ahead and kind of just visualize them. Imagine us on a number line, right? When we're discrete, the values are indistinct or individual from each other, right? So maybe we're looking at 1, 2, 3, 4, and 5, right? And so there's only 5 items in a discrete set. So there's distinctly the number 1, there's distinctly the number 2, there's distinctly the number 3, 4, and 5, and nothing in between. So there's only 5 items in this set. And the way we would designate that is we use curly brackets, are the way that we designate that I have a set that's discrete, and then we just simply list the 5 items that are in the set. So I'm basically saying there's only 5 items in that set. Interval is different, right? Same picture. We're going from, let's say, positive 1 to 5 again, right? And then even this kind of stuff starts to happen. But now what we're doing is we're talking about an interval. We'll color it in. So we are truly talking about, one of my boundary points is 1, another boundary point is 5, and we're talking about everybody in between. And this is what we call an interval, and we use interval notation. This closed dot means that 5 is included, so we use a bracket. This open dot means that 1's a boundary, but it's not included, so we use a parentheses. And so this is what we usually use for interval notation. Of course, if I'd have had this closed and this closed, right, we'd have had why do I keep writing -1? We would have brackets and brackets. If I'd have had it open and open, then we'd be using parentheses. But either way, I have a whole an infinite number of solutions, right? Everybody between 1 and 5, and whether I include those endpoints gives me parentheses or brackets, and etc. So there's, in our domain and range discussion, this is how our domain and ranges will be. They're sets. They're either discrete sets, nice distinct values, or they're intervals. We're talking about everybody between 2 given numbers, a high number and a low number. The interval notation for that one, discrete notation for discrete. Okay? So with that being said, let's go to these relations that we had earlier, right? What is the input? Well, this is the domain. What is the output? We are now calling that range. And again, in terms of what's in there, we have to be able to put, we just can't put any student into the GCC function, right? This student has to have a list of accomplishments, or they have to meet some criteria. They have to be able to pay their tuition. They got to be old enough to be able to sit here and watch this video and do their homework. Like, for example, my grandson right now is just 1 year old. He's not going to make this GCC. I could put him in it, right? I can make him sit here and watch this video, but he's not going to know, he's not going to be able to make this function, or this, excuse me, relation work to get over to this part over there. So you can kind of see there's again, we're just not talking about anything I could put in, right? It's got to be something I can put in that actually makes the function work. And so for this one, I would probably use a discrete set, and I would just start listing names of people, right? Like Frank, right? And Liz, or Maya, or whatever. So this is basically a discrete set, because it's not, we're not talking about, there's no interval between Liz and Maya, right? Liz is distinctly in this set, or Maya is distinctly in the set. The dot dot dots means there's more people in the set, all right? And so so basically that's how we describe that. Same thing with the matchmaker relation, right? The person, these are distinct people. There's not, I mean, we could talk about a range of values, and a range, we can even try to score it, right? If I'm in my matchmaker and I'm trying to score, like, where's my political leaning, left or right, right? We can even score it. I'm 5 to the right, or I'm 4 to the left, or whatever. So we can give those values, if you would, but they're still distinct values. They're not an interval like we have here, right? They're distinct values. So again, I would say that this domain, or would be a person. So again, maybe it's Frank, maybe it's Liz, maybe it's Maya, right? And on and on and on. The job pay. Again, it's not everybody, right? We don't work negative hours, right? Even though in this formula I could put a negative number in there. 12 times -1 is a -12. So I can do it, but it doesn't make any sense for the real life application of that. So, and this one's actually an interval, all right? Or it could be discrete, depending on, maybe your boss doesn't pay you for 1.25 hours. Maybe they only pay you for 0, 1, 2, 3, or 4. So, that could be a discrete case, or we can be talking about an interval. And maybe they cap off, right? I can only work from 0 to 40 hours. So that would be my interval of possible hours worked, assuming I get no overtime, or assuming they're going to pay me for like 1.3 hours or 1.1 hours or 5.675 hours. If they don't, it's going to end up being discrete. What about my list of pay? Well, if just kind of use our formula to kind of get a feel for that. At the low end, right, 12 times 0 is 0. So my pay can be anywhere from 0 all the way up to 40 times 12. Right, and let me do some math here. 0, 8, 480. So my pay would be anywhere between 0 and 480. So there would be an interval, right, matching that interval, right, for work. And just to give you an idea of how we use discrete sets, right, or interval sets to describe our domain and range. All right, so now that we've got them defined, let's go do some practice and put them into action. See you guys in the next video.